The components of the Transreality Storyboarding Framework consists of 3 sections. The first, the 8 reality design methodology, looks at all the different realities that are typically worked with in any kind of framework that relates to the extended reality spectrum. The second component looks at the interactions that are involved in the experience that include passive interactions as well as more interactive experiences and even experiences shared over networks. The third section looks at how realities are engaged with using particular senses, whether they're physical senses, whether they're data streams coming from sensors, or whether they're to do with non-traditional senses, such as a sense of direction or a sense of time, and how each of these links in with the realities through the interfaces and the kinds of interactions that we see in pairs. Together, these 3 sections come together to form an overall experience space that people are going to encounter when they are going through a particular narrative or story that's being told through the XR spectrum. The first of the sections is to do with the 8 realities that are typically worked with in XR productions and XR experiences. These are things that many people are already familiar with, but they typically are stories that begin with everyday reality and involve using someone's imagination and the reality of ideas that people have within their imagination. So these can be considered realities in their own right. It's arguable about which comes first, but usually it's everyday reality that influences our imagination and its reality and the ideas that are there. And these are usually captured in one form or another through photography, through illustration, or through scanning, video, amongst other things. And once these are captured, then they're processed usually within a computer in some kind of way, whether it's computer-aided design or whether it's through some kind of hardware processing. And once that's done, usually the models or the outputs of those are fed into some kind of output medium. Output mediums include 3D printed reality, augmented reality, as well as virtual reality and newer forms of reality that we see in devices like Microsoft HoloLens and Magic Leap that include extended or holographic reality. That's a term that's normally interchangeable with things that people refer to as mixed reality. Typically, a journey is done starting from the beginning and going further down the list of realities. A journey doesn't have to go through all of the realities, but it typically has to begin with an idea or something in the world that's captured and generated inside of a computer, and then it usually gets output in some form, either in 3D printed reality, augmented, virtual, or extended reality. So the key principle that comes across from this is we're not just working across mediums, we're actually working across realities. And if someone's learning an experience or going through an experience, they, just like with conventional stories, how there's a story that covers an arc of ideas or an arc of a plot, a story plot or an arc. In the same way, there's an arc of learning as people go through the different realities in order to build or produce an extended reality experience. In the case of architecture, for example, someone might start with everyday reality and then take ideas ultimately through computers and output into 3D printed reality or augmented reality, like a building, for example. So that's an example of a possible route through the 8 reality design methodology. But there are lots of ways through it, but typically they start at the beginning at the everyday reality level, and they end up as an output form, typically of 3D printed, augmented, virtual, or extended reality. The realities in themselves can be described in very specific ways. I won't go into too much of a description here because there'll be a later video which explores the realities in more detail. But the summary of the realities and exactly what they do are shown on this slide. And this is a summary of all the things I've just said in the previous slide. The second section of the Transreality Storyboarding Framework is how the realities are engaged with through specific kinds of interfaces or interactions that are determined by what kind of sensory engagement is required for the experience that we see through Contextology. So if somebody was just watching a video, for example, without interacting with it in any kind of way. That would be an example of a passive experience where there's no exchange going on between the viewer and the content. The viewer is simply passively looking at the content and experiencing it. On the other hand, if they are using an augmented reality app, for example, and they want to change the color of a car they're looking at, and they push a button and that changes the color of the car, that's a one-way change of information in the scene. And that's an example of an active interface. If it's two-way, then the car can do something, not just change color, but it can perhaps provide further instructions to the person to do things that enable them to get more into the experience. So if there's a two-way exchange between the user and the application, then that's something that we would typically call an interactive experience. Sometimes there are interactions which don't just come from the user or from the app. They may come from external sensors. They may come from data streams which are outside of the app, but not necessarily going over an external network. They are local to the experience. In such cases, the app or the user is responding to sensory streams from their local environment. So if there's that kind of interaction, then that would be called a responsive type of interaction or interface. Lastly, if someone is connecting into an experience, but it's a shared experience in that the scene is something that's been contributed to by people in other parts of the world over the internet or over Wi-Fi, for example, over a wider area network, WAN, then that's something that would be considered to be a shared experience or something that's carried out through a shared interface. So if someone creates an experience and shares it over the internet to a cloud repository and other people download it, for example, AR content that's created by one person can be put into a cloud-based database and then picked up by other people to use, and even shared experiences like shared design of a building or shared experience of a surgical operation. These are examples of shared interactions, and they typically will have shared interfaces to help them be manifested and be worked with. Together, all these types of interactions spell out the word pairs, P for passive, A for active, I for interactive, R for responsive, and S for shared. When we look at the realities and we look at how we want to engage with those realities in a particular experience, maybe we want to work with 3D printed in a way where we want to see what's 3D printed, but we also want to be able to touch it. In the case of augmented reality, maybe we want to also hear things, or in virtual reality, we want to actually pick up someone's voice and get it to change things in the virtual reality experience. These are all examples where we want to engage the senses in some kind of way within that reality. Now, wherever we're engaging a particular sense in the reality, it's going to have to be done through some kind of interface. In the case of seeing things, there's going to need to be a display. There's going to need to be some menus or buttons that people can push. In the case of sound and audio, there's going to need to be a microphone to pick things up and speakers to actually present what's been heard. But in terms of an interface, there may be some specific menu items that are required to turn up the volume or actually switch frequencies that are being heard. So each of the senses, whenever they have a role to play within the XR experience, there's going to be an interface of some kind. There's going to be some kind of link or portal through which that experience is carried out. Now, the senses can be certainly physical to do with the additional 5 senses that we have, but they can also be sensory information that comes from sensors. It could be a stream of data relating to someone's temperature, for example, or their heart rate, their beats per minute. But it can also relate to non-traditional, non-physical senses, such, for example, as our sense of direction or our sense of time. These are things which we can't necessarily point to, but they are nevertheless things that we have a perceptual experience of. So sometimes maybe you want to give someone an experience of time speeding up or time slowing down, for example. We want them to have a sense of knowing which direction they're going. So there might be an interface which points towards the direction that they're aiming for. So these are non-traditional senses, but nevertheless, they are things that are cognitively experienced and felt, and therefore we might want to include these things too. Wherever there's one of these senses senses or types of cognitive experience, and it's being experienced in one of the realities, there's a tick corresponding to that in each of these boxes for this particular experience that you're seeing here on the screen. Wherever there's a tick, whether there's a sense that links in with the reality, there has to be some kind of interface to manage that exchange with that particular sense. And this is where contextology comes in. It's something that looks much more closely at how senses are worked with in reality, whether it's everyday reality, whether it's in virtual reality, or whether it's in augmented reality. In the next slide, we can see an overview of the Transreality Storyboarding Framework. As we can see from the beginning, there's the 8 realities design methodology, there's the pairs UX interaction spectrum on the left, and lastly, there's the section that corresponds to how senses are engaged with and how perceptions are managed in realities, and that's covered by contextology. Together, those 3 segments come together to form the components of the Transreality Storyboarding Framework. And one of the outputs is having a clear map or matrix of how each of those components are related to each other, how the realities that we can see on the vertical part of the matrix are linked to the contextology elements relating to the sensory channels. And wherever the sensory channels cross in terms of their columns and rows, that's where we get an interactive element comes out that relates to pairs. So, for example, we can see that in the first black arrow that we see, where in augmented reality experience, one of the things that's going to be engaged with is what people are going to see. They're going to encounter a video, for example. That's an example of a passive video. In the case of the virtual reality part of the experience, there's some voice control, as well as some sound relating to a voiceover. And that's an example of an interaction that's active, because voice control is something that can make something happen within the scene, but it's still a sound. Similarly, with the holographic experience, you can see the hand gestures, which count as haptic or relate to touch, parts of the sensory spectrum of contextology. They're used to interactively control a scene in the holographic experience. In use cases that we'll talk about a little bit later, we also include situations where we're reading information from sensors, and these include temperature sensors and heart rate sensors to determine what someone's state of mind is in a holographic training experience. So you can see that that's more of a case of responsive type of interaction where the temperature is being measured. But those training experiences are often shared over the cloud so other people can use them, and those training experiences can be co-experienced with other people together in a live simultaneous way. And those 2 kinds of things are examples of a shared interaction where the training is relying on things over a network in order for people to experience the training, but also share common assets such as media files and models and things like that in a repository online in a cloud-based database.
So to dive a little bit more into contextology, contextology is the study of context, or the science of context engineering. And context engineering focuses less on engineering content and instead attempts to manipulate and create context directly. This is achieved primarily by reconfiguring our own perceptions, individually or in groups, as the primary content. This pursuit of these new states of perception is intended to enable novel cognitive and creative insights. We can now adopt radically different visual or auditory systems, spend time out of body, in the third person, or focused in peripheral vision. We can also body swap or gender swap. These can all be achieved through the practice of contextology. So in terms of contextology as a field of study, a major impetus for this work is that through the use of contemporary AR, mixed reality and XR technologies, the redefinition of internal contexts, i.e. subject perceptions, are more broadly accessible and adaptable than ever before. This relates to the powerful ability these technologies have to trick the brain into accepting new inputs as new realities. Human-computer interaction frameworks must take into consideration the new possibilities that are being offered by context engineering, because if the senses themselves have been augmented, then the usual rules outlining appropriate human-computer interaction must also adapt and evolve accordingly. AR, mixed reality, and XR technologies are all about experience. Imagine an internet of experiences, i.e. contexts, rather than the usual internet of information, i.e. content. Contextology focuses on the role of human agency in the interplay of generating new internal, i.e. subjective, and external, i.e. objective, contexts, and thereby realities. So moving on to the contextology typology, in order to reliably augment our perception across contexts, the science of contextology creates frameworks of use via a collection of types. This results in a typology which houses collections of the types of function you would expect to encounter. The purpose of a typology is to offer distinct ways of understanding how context engineering is taking place. For example, one method is to break it down into the senses. Visual, audio, touch, smell, etc. Of course, some types are deployed across several senses or rely on the synergizing of a range of senses. The second method would be based on experience. For example, out-of-body experiences via selfie drones, an Airbnb of bodies when you're using volumetric display and capture, or adapting inputs, i.e. resizing the food that you're eating whilst you're eating it via AR mixed reality glasses, filtering out sounds that are there in the actual environment but are no longer being listened to or heard through your hearable, or turning up the bass, again through a hearable, or translating inputs, i.e. stimulating the vagus nerve whilst you're doing other activities. So in terms of the philosophy, a great quote, context engineering, the real voyage of discovery consists not in seeking new lands, but seeing with new eyes. If a picture is worth 1,000 words, then context is worth 1,000,000. And a nice example of this in action is, we all know that most VR experiences are just a visual and an auditory experience. Bloodsport, which was a Kickstarter, funded on Kickstarter in 2014, actually included, it was a gaming experience, so you were tied up to an Oculus, and it's a typical shoot 'em up game, but you're also linked up to a drip. And every time you got shot in the game, you also had blood removed from your body. So this is increasing the amount of context that's used in that experience. So not just your sight and your hearing, but also your body is involved. And you know, this is what's really interesting, is that most experiences are not using enough of the context, and contextology is enabling people to understand that. So also some context engineering tools. We mentioned volumetric capture. At Ravensbourne University London, we built a holoportal, which is a volumetric capturing studio. So anything that goes in there can be turned into a hologram. So we're working with Microsoft to produce content for the HoloLens. And that content can then go into many contexts. So it can go into animations, it can go into films, and it can go into immersive experiences. The second one along is a head-mounted device that basically gives you 360-degree vision. So it takes a 360 input from this camera and squashes that 360 input into a 180-degree visor. So your normal field of view would be 180 degrees, but now it becomes 360 degrees. It only takes 15 minutes to adjust to that new reality, and this absolutely fundamentally changes your context. And I've worn this device for a week, and I got used to it within a very short period of time, and didn't really want to give the device back. This one here is based on work done in Japan, where we worked on these diet goggles. So you're again wearing mixed reality, and you're increasing the size of your food whilst you're eating it in order to trick the brain into thinking that you're eating more or less than you actually are. Also in Japan, the teleexistence system was used in order to enable you to enter the body of a robot. So you're wearing smart gloves and smart glasses. You look down at your body, you're basically a robot, and you look to your right and you're sitting next to yourself. An incredibly profound experience. For instance, Professor Anami, who I was working with there in Keio University, immediately changed his job as a result of a 5-minute experience in the teleexistence system, which has been built 20 years ago now. Also prosthetics. This is the additional thumb, which again enables entirely new realms of human-computer interaction. And finishing off with the decelerator helmet, which slows time down in real time, giving you access to patterns that you would never normally have access to.